Assalamualaikum. Today we are going to collect samples from Taman Tasik Studio. So let's go.
These are the apparatus and material used to conduct a jar test. These are the apparatus used, which were measuring cylinders, beakers, pipette, sample cells, and jar test machine. Before conducting jar test experiment, these apparatus were labeled and set up. These are the procedures to conduct jar test. There are 6 procedures. Firstly, prepare sample by pouring the water sample into 6 different beakers and set the number of beakers from 1 to 6 and 6 as the blank sample. Water sample was measured by using measuring cylinder before poured into beaker. As you can see here, the beaker was labeled from 1 to 6 for each beaker. Aluminium sulfate solution was used as the coagulant with increment of 2 ml in each beaker from 1 to 5. As for beaker 6, it is labeled as a blank sample. Next, measuring cylinder was used to measure the amount of aluminum sulfate solution used for each beaker. Each beaker has increment of 2 ml and beaker 5 has the highest value of aluminum sulfate, which is 10 ml. After measuring the coagulant used, pour the aluminum sulfate solution into each beaker. Make sure the coagulant used was accurately measured before pour into the beaker. Aluminium sulfate solution was poured into a beaker. Now, put the beaker into jar test machine and make sure the label can be seen. Next, set up the mixer and lower the propeller into the jar and avoid it touching the base of the beaker. The machine was switched on and the light was switched on too. Next, for the rapid mixing, the machine was set for 130 rpm and for 3 minutes duration. After done with the rapid mixing, now for the slow mixing, the machine was set to 330 rpm for 50 minutes. After done with the slow mixing, the jar test machine will switch off and let it set for 50 minutes before starting other tests.
So continue with the pH testing. So this is the procedure of the pH testing. According to the procedure, we need to press the exit button first. So this is the probe testing. Before testing, we need to rinse the probe with distilled water. Then we press the read button and wait until it's stable. The log will be displayed. And then we will record the reading. After taking the data, take out the probe from the sample and rinse again with distilled water. And then press again exit button and repeat the procedure with a water sample with different coagulant.
Moving to the next, which is the turbidity test. First, prepare 6 clean sample cells and mark them from 1 to 6 using a marker pen to match each of our jar test dosages. Once the sedimentation phase is complete, carefully collect the clear supernatant from the top of the first jar by pouring it into a separate small beaker, ensuring you don't disturb the settled flocks at the bottom. Next, gently pour the water sample from the beaker into its designated sample cell up to the fill line, making sure no air bubbles are formed. Repeat this collection for all 6 jars. Take the first sample, cap it firmly, and use a lint-free tissue to thoroughly wipe the exterior glass from top to bottom to remove any dust or fingerprints. Now, turn on the turbidity meter by pressing the I/O exit key. Hold the wiped cell by its plastic cap and carefully insert it into the cell holder. Once inserted, press the signal and range key, then press the auto range key until the word auto range appears on the screen. Press the read key and wait a moment for the reading to stabilize. Once the value stops blinking, record the turbidity in NTU for this specific jar. Remove the cell and repeat the measurement steps for the remaining 5 sample cells. Once all readings are recorded, press I/O exit to power off the machine and clean up your workstation.
Procedure for color testing is, first thing first, we need to turn on the spectrophotometer and we need to wipe the outside of the sample cell with tissues to remove fingerprints and water droplets. Next, we need to place it into the spectrophotometer. After that, choose start program, insert 120 for color and press start. For blank sample, we need to press 0 and wait until the readings appear on the screen. After that, take out the blank sample and repeat the step of wiping the outside of the sample cells with tissues to remove fingerprints and water droplets and place it into the spectrophotometer. For the labeled samples, we need to press read and wait until the reading pop out on the screen. Record the data and repeat the steps for other samples. And finally, turn off the spectrophotometer.
Next, this slide presents the result and analysis obtained from the jar test experiment using aluminium sulfate as the coagulant. Different coagulant dosage of 2, 4, 6, 8 and 10 ml were tested to determine the optimum dosage for reducing turbidity and color while maintaining an acceptable pH. From the table, the turbidity decreased significantly as the dosage increased from 2 ml to 8 ml. The lowest turbidity recorded was 2.91 NTU at 8 ml. However, when the dosage was increased to 10 ml, the turbidity increased again to 4.89 NTU, indicating that excessive coagulant can reduce treatment efficiency due to overdosing. The pH values remain within an acceptable range throughout the experiment, with a pH of 6.32 recorded at the optimum dosage. Meanwhile, the color was reduced from 320 pt/co in the raw water to 43 pt/co after treatment, showing that aluminium sulfate was effective in removing suspended particles and colored substance from the water. This figure also illustrates the relationship between turbidity and coagulant dosage. The graph shows a decreasing trend up to 8 ml, followed by a slight increase at 10 ml, confirming that 8 ml is the optimum dosage for this experiment.
The aim of this jar test was to determine the optimum dosage of aluminium sulfate, also known as alum, for treating raw water. Alum is used as a coagulant to remove suspended particles by helping them stick together to form larger flocs, which can settle at the bottom of the jar. In this experiment, 5 different dosages were tested, which is 2, 4, 6, and 10 ml. The effectiveness of each dosage was evaluated by measuring turbidity, pH, and color. First, let's look at the turbidity result. The water sample had a turbidity of 30 NTU. As the alum dosage increased from 2 ml to 8 ml, the turbidity gradually decreased from 21.8 NTU to 2.91 NTU. This happened because more suspended particles were able to combine and settle out of the water. The lowest turbidity was recorded at 8 ml, showing that this was the optimal dosage. However, when the dosage was increased to 10 ml, the turbidity increased slightly to 4.89 NTU. This is because adding too much coagulant can cause overdosing, where the floc become unstable or break apart and leaving more particles suspended in the water. Next, the pH changed with the different alum dosage. The pH decreased from 5.68 to 5.01 as the dosage increased to 6 ml, because alum releases hydrogen ions when dissolved in the water and making the water more acidic. At 8 ml, the pH increased slightly to 6.32, which is close to the suitable range for coagulation, while at the 10 ml, the pH dropped slightly again to 5.99 due to the extra alum added. Overall, the pH remained within the acceptable range for raw water, although a small pH adjustment may be needed before the water is suitable for drinking. The color of the water also improved after treatment. The blank water sample had a color value of 320 pt/co. As more alum added, the color gradually decreased, reaching 32 pt/co at 10 ml. This happened because of floc trapped color, particle, and organic matter before settling. Although 10 ml gave the lowest color value and it did not produce the lowest turbidity. Therefore, 8 ml was chosen at the optimum dosage because it gave the best overall performance by producing the clearest water while maintaining a suitable pH. Finally, the results were compared with the water quality standard. At the optimum dosage of 8 ml, the turbidity was 2.91 NTU, which meets the Malaysian drinking water standard of less than 5 NTU. However, the pH was slightly below the recommended drinking water range, and the color value was still higher than the standard. This means that although coagulation removed most of the suspended particle, additional treatments such as filtration or pH adjustment would still be needed before the water is safe for drinking. In conclusion, this experiment showed that aluminium sulfate is effective in improving water quality. The optimal dosage was 8 ml because it produced the lowest turbidity and gave the best overall treatment result. used too little coagulant does not remove enough particles, while using too much can reduce the treatment efficiency due to overdosing. That's all.